Okay, here we go. Yep. Switch problem D to a plus. Problem D to a plus. Stop it! I don't like it. It hurts. All right. Oh boy. You guys should write a book on immaturity. I mean, and you just sign your names. Everybody would buy it. They'd be like, excellent authors. All right. Graphs of sine and cosine functions. Today we're going to do amplitude, period, but we're also going to do horizontal and vertical shifts. You guys know how to do all this material already. You do. And it's just a matter of getting used to sine and cosine. So we start here. Sine and cosine functions have this shape as we list them out. Any idea what the amplitude will be? Absolute value of A. For both sine and cosine. Any idea what the period will be? 2 pi over B. And B is the value in front of the x. Some people got confused second hour. They're doing 2 pi divided by C. No. What do you think the vertical shift is? D. The horizontal shift is bx minus c equals 0. Solve for x. So, yeah, you generally get c over b, but anyway. Okay, so when we actually apply this, we actually start here. This is our first one, and we go 2, 3, and 4. So we actually do the vertical shift first, because that's easy to just kind of get everything out of the way. Now, if you got your own way of doing this, you go ahead. You own your mathematics, do whatever you want. This is just my suggestion, and generally people like it, so do what you want. Let's do B first. Okay, we start by identifying the vertical shift. What is the vertical shift? Vertical shift is 2. So I draw a horizontal axis through the vertical shift. The nice thing is if you know how to do this, you'll be able to graph secant, cosecant. But I promise you, if you can't do what we do today, you'll have absolutely no idea how to graph secant and cosecant. You have to be able to do this in order to do the others. There's no way around it. Okay, so I'm going to mark off 2, 1, 2. And I'm going to draw a horizontal axis right through there. Second of all, we identify our amplitude. What's the amplitude? And so once we identify the amplitude, we then mark off max and min from the shift. So if I'm going to go 3 units above and below that horizontal shift or vertical shift, how high am I going to go? 5. I go up to 5. How low will I go? Don't need to laugh at me. Okay, good. Up to 5, down to -1. So we've taken care of the first 2 pieces. My third piece will be to identify the period. This period, 2 pi. And so the period, divide into 4 parts. Why 4 parts? 4 quadrants. You guys must have had a really good teacher the past couple of days. I just want you guys to know, like, over break, if you ever, like, need to watch a YouTube video because you miss my voice, that's totally normal. Stalker. All right, and then last of all, we identify the horizontal shift. But before we identify it, okay, this is an important part. Sketch dotted graph. Whoop, I'm sorry. That's supposed to be between 3 and 4. Sketch. You just draw an arrow. So before you apply a horizontal shift, I think it's best if students start drawing a dotted graph right away, because the horizontal shift can get confusing. Now, is there a horizontal shift here? No. The horizontal shift would be 0. So instead of just drawing a dotted graph, we can actually draw the actual graph right now because there is no horizontal shift. The graph is cosine. Will it start at the center or will it start at the max or min? It starts at the max because it's cosine and it's positive. So I will start up here at the maximum. Instead of crossing the x-axis, I cross the value 2. I cross the horizontal axis that we shifted. At pi, I'll go all the way down to -1. 3 pi over 2, I will be up at 2. And at 2 pi, I'll be up at 5. And I can back out of this if I want to the other way. There I have my graph. I will sketch it. There we go. What do you think? Pretty good? Let's check it on our calculator. Three cosine of x plus 2. Remember, you need to be working in radians, not degrees. If I go into window, my x minimum value is -pi. My maximum value is 2 pi. My scale is pi divided by 2. My y minimum. Now, so I see the whole viewing window here. I'm actually going to put my y minimum at -5. So it will look in relation to what I actually have on my drawing. I press graph. What do you think about that? It's pretty accurate, isn't it? Yesterday we got 55 seconds, but that was just with period or amplitude. This is definitely going to take a little longer, right? Minute and a half. But that's okay. Question, Hannah. Yeah. -pi is my x min. 2 pi is my x max. 5 is my y min. -5 is my, or 5 is my y max. -5 is my y min. Got it? Well, the scale, a tick mark every pi over 2. Yep. Well, that's the minimum value of it, but Hannah, I wanted the graph to actually show this whole region. So even this space at the bottom, that's why I went all the way down to -5. Does that make sense? So now you see that space at the bottom just like we have here. That graph looks like a snake. Julie, is that your graph? You might have to get some extra practice. Extra homework for you over break. Okay, let's try another one. This one does have a horizontal shift. It doesn't really have anything else that's happening. First of all, what is the vertical shift? Nothing. So I'm just right along the x-axis. What is the amplitude? 1. What is the period? 2 pi. Now this is where people made mistakes second hour. It's the 1 in front of here that you're using for 2 pi divided by b. It's not the pi over 4. That's your c value. Okay, so I got through 3 steps, so I should sketch the graph before I do the horizontal shift. Do people recognize what the horizontal shift is? If you were to solve this inside equal to 0, what would you get? X minus pi over 4 equals 0, so x is pi over 4. So that's going to be our shift. Before I apply that, I'm going to draw a graph. I'm going to draw it in blue. My amplitude is 1. Go up 1, down 1. Divide it up into 4 pieces. This is a sine graph. Does it start at the middle or does it start at the max or min? Middle. Is it going to start by going up or down? Up. So right now all I'm doing is drawing the parent function of sine. Any questions about that? No. If you are ready to move along, you go ahead and do that. Oh, okay. The reason why I'm doing it now is because I'm going to now apply the horizontal shift. And if I can see the parent function, or kind of the original that the shift came from, it's going to help me as I sketch this graph. Now, pi over 4 is my shift. How does pi over 4 relate to your scale here? Half of one of the scales. Pi over 4 is half of pi over 2. So all of these points, I'm going to shift them over pi over 4 units, or half of a scale marking. So I'm just going to take all these important points and just shift them over to the right, pi over 4. And now, if I sketch my graph, which is infinitely better than yours, because I practice all the time. Take that. That's my new graph. Somebody think they have a really good graph? Julia, you may not show yours. Casey's covering up her paper. It's a very nice graph, Tara. Jensen. Very nice, Casey. Jesse, Andy. Ooh. Mallory's is pretty good. Oh, wow. Regions is the best so far. All right, let's check our calculator to see how accurate it is. Now, if you don't want to type this in, you don't have to. Just watch mine. I'm going to do sine of x. And then I'm going to do sine of x minus second pi divided by 4. And I'm going to make that one bold. And I'm going to go into my window. And I've got negative pi to 2 pi. Scale is pi over 2. But my y min, I'm going to make it negative 2. And my y max, I'm going to make positive 2. That will probably suit the window I have. And if I press graph, again, I think this looks really cool. There's my blue graph, right? That's exactly what I have. You can see the red graph in bold right over it. You can see the horizontal shift that takes place. The red is the only one up here that's the actual graph, right? I just used the other to sketch it. So it's kind of a skeleton. It's helpful. And we'll do that a lot with secant, cosecant. Okay, let's try another one. Okay, we'll try to ramp up the speed a little bit. C. I start with what? What's the first thing I look for? Vertical shift. What's vertical shift? -2. What's the amplitude? 4. So I'm going to have to go up 4 and down 4 from the vertical shift. So what's going to be my lowest value that I'll get to? -6. So I'm going to have to make sure that I have -6 on this graph here. And looks like I'm good there. I'll go all the way up to +2. Those markings are fine. And again, we have this horizontal axis that flows right through -2. So I just covered the first 2 steps there. Is everybody good with that? Okay, the next step is just like from, yesterday. I take 2 pi and divide it by b to get the period. What's the period? Period's 2. Take 2, divide it up. What's the horizontal shift? One over pi. I got to add the 1 and divide by pi. Remember, I saw pi x minus 1 equals 0. Add the 1. Pi x is equal to 1. Divide by pi. X is 1 over pi. That's what we did. What is 1 over pi? Somebody here calculator real quick. 1 over pi. 0.3? Okay, about 0.3. So horizontal shift is about 0.3. Okay. How does that relate to my scale? Is it? I move it to the right. A full scale, less than a full scale? Less than, yeah. 3/5 of a full scale, right? Okay. So, about half, a little bit more than half. So we'll do that. First, let's sketch the skeleton of this graph. And I'll sketch the skeleton in red. I'll sketch the final one in blue. Okay? So this is cosine. Does it start at the middle, the max, or the min? It starts at the max, but because it's negative, it starts at the min. It's going to start all the way down here at -6. Will I start by going up or going down? Going up, I will cross over the axis. I will top out. Value of 1, I'll get 2. Come back down. So on and so forth. This is my skeleton. Or my scaffolding, however you'd like to refer to it. Or my dotted graph. That's just so boring. Any questions how I got that? Okay, now I shifted 0.3. So I'm going to take all these points. So I locate any point on here, I just shifted over 0.3 units. And, no, this is not exact, but it's pretty darn close. And if we were to type this into our calculator, which we won't do, just for the sake of time right now, but you'd come up with something pretty close to this. And again, first semester, just about every day in this class, we were covering something that you'd done before. Now every day we're covering something you haven't done before. So it should be exciting. You're learning new material. Some people were saying second hour after we got through this example, they're like, oh yeah, I kind of like this. They didn't want to say too loud because then they would start identifying with me and kind of feeling like they were a lover of mathematics. And that's okay. You can like this stuff. It's normal. You guys would start to get to this stuff. A lot of people do. They did last year. And they start to say, hey, this is actually pretty cool. And you can feel that way as well. You do? Tara feels that way. Thank you. Any question on that before we move on to the last one? Yes. So the horizontal shift is 0.3. You see how we got 0.3? We took the inside, pi x minus 1 equals 0. We solved for it. We got x is 1 over pi, which is 0.3. Then I took all of the points I just shifted them that way 0.3 units. This distance right here in green is 0.5. So I just moved them shorter than the 0.5, about 0.3. Does that make sense? Yes, the horizontal shift is always along the x-axis. The vertical is what we apply right away. That's all right, Casey. We'll find a good time we can laugh at you. All right. Okay, last one. If you type them in, yes, it'll... Turn on, stupid calculator. Okay, the very first one. We'll do the... If you want to help her, go ahead. Otherwise, Hannah, we'll look at it right at the end as well. Okay. All right. I start by identifying the vertical shift. What's the vertical shift? 3. What's the amplitude? 1. So if the vertical shift is 3 and the amplitude is 1, what's the largest value that this function will achieve? 4. What's the lowest value? 2. So I'm going to go up to 4. 1, 2, 3, 4. We said that you have a vertical shift of 3. And so I'll go up to 4 and I'll go down to 2. Any questions how I generated that? Okay, just doing that one, those 2 steps, you're halfway done with this. What's the period? Good, the period is pi. So I take pi and I divide it into 4 parts. Horizontal shift, I take the inside, 2x plus pi over 2. We switched that for the problem. We set equal to 0 and we solve. 2x equals pi over 2, negative pi over 2, divide by 2, x equals negative pi over 4. Horizontal shift is negative pi over 4. How does that compare to our graph? It's 1 tick mark to the left. Very good. So before I apply that horizontal shift, I'm going to sketch the skeleton of the previous one. And the signs start in the middle, max or min. Middle. This one I'm going to start by going up or going down. Down because it's negative. Okay. Now I shift everything to the left, pi over 4 units. So I'm going to shift it back. All these points just shift back. And they shift back 1 tick mark, because every tick mark is pi over 4. And some people get to a point where they don't really need to do that anymore. They're able to just do it without actually making the skeleton. They can just go ahead and shift it every time. I find that that's too big of a step to make for most students, so I teach it like this. You know, if we were to graph it, that's actually a really good representation of the graph. Do you want to see it on the calculator? Okay. Are there any questions before I show you your assignment? You're not learning anything new tomorrow. We're going to continue graphing sine and cosine functions. Tomorrow will be a light day. Maybe a couple extra problems to work on. Give you some time in class to work. There you are. So your assignment is section 5.3, page 439, numbers 21 through 23, and 27 through 32. I just wanted to bring up one thought, you guys. If your book has a problem where it puts a 1 plus in front of there, what can you do? Yeah, just move it to the end. Put the +1 on the end, and get rid of that. So addition is commutative, so you can move it around. So that's what we do. Sometimes people want to see a video. So my father-in-law might say, Kevin, I want to see what you guys, what does this YouTube thing look like? So I'll pull up a YouTube video and I'll show him my account and stuff, and so I watch it. Sometimes I will watch a video if like for example, calculus is the hard one. Sometimes I'll get to something in calculus, I'll think to myself, I was like, I know how I would have taught this 3 years ago, but I don't remember how I taught it last year. So I'll watch a video for a short while to remind myself, because I keep them year from year. That's actually really helpful. Sometimes I watch a video, like if I'm getting observed, to critique myself. When I listen to myself and I watch what we're doing, there's sometimes I'm like, okay, that totally made sense. Like if they didn't get it, they weren't trying hard enough. And other times I watch, I was like, that sucked. Like if I was watching that class, I would have raised my hand about 15 times. So, it's a good way to try to, analyze your teaching. It's kind of embarrassing. I'll tape record myself, once a year or so, and then go back and watch it. And it's kind of humbling when you watch yourself. Like, I don't know if I would have done it. And then some days I'm just on fire. I mean, I'm funny. I'm getting Mallory to laugh. Eating cupcakes. Maybe one day I should just do a whole YouTube video and do it entirely incorrect. And see how many people actually pick up on it. And then somebody will record and say, math, or worst math teacher ever. We'll see. All right, there you go.